Okay, since there wasn't homework, there's no daily quiz. Go and get your food because Andrew actually followed through. I didn't expect that soon. I figured we'd have to rib him a little bit first, but.
What? I actually didn't do a bad job.
And by I, do you mean your mom?
No, I made these myself.
That's what I asked him. I said, did your mom make them? And you said,
Huh.
she made them.
Yeah, my mom left
He's
last night.
surprised
She
you
was
every
like,
day.
"Here's a recipe." I was like, "Thanks." Yeah.
Cool. And we're just going to get into it. So, since we only did one example, I'm going to do it again before setting you loose. Especially since there's that, whole 24-hour gap there. Stage one. If you can factor anything, factor it. When I see that, now it doesn't always work out this way. You don't always have the same denominator on both sides by factors. You might have 4 different sets of factors here, 5 different sets of factors. The uglier ones will. But in this case, actually ain't so bad. All you got to do is, where are you? There you are. This one is missing a x minus 6. And this one is missing a x plus 3. So now, this is x minus 6 plus x plus 3. This is x minus 6, x plus 3. This is x minus 6, x plus 3. They all have the same denominator. So while I'm at it, y'all okay if I also womp like that?
Good job, Andrew.
Thank you. Are they pretty good?
But we needed common denominators to be able to do that.
Yeah, I know.
The orange stuff is to get the common denominators. Yellow, it will now just yeet the whole denominator. Gone. Yes. Okay. The key was to get these to the numerator. Because now, if they all have the same denominator, I multiply them all by that denominator, denominator go bye-bye. And we're left with 2x squared minus 6x, 12x, right? Plus 3x plus 9 is 27. Okay, so you have to get the common denominators in order to actually add together the numerators. Once I do, that's just a quadratic. Get 2x squared minus 9x minus 18. If I subtract 27 over.
Oh, yeah.
And factor. I'm just going to run straight for this because 2 is prime. If you're in here, odds are you got the mental math mojo to run through the factors of 18 real quick. What do you think? Hmm? Right? Negative 12, positive 3. When you distribute. If you got to go full AC method on it, do it. Okay. I get all the way down to x is a negative 3/2 and a positive 6. But since my original equation had x's on a denominator, that means I had the potential to break the first commandment of domain. Thou shalt not divide by 0, so womp womp. Now you should also actually check that answer. Okay. You should also check that answer because there's the possibility that you do this whole honking thing and it ends up being like positive 5 equals negative 5. So it still doesn't work. Usually it's just the thing that makes the denominator not work. Negative 3/2 will work. So there we go. That's the one. You need to go get yourself some common denominators. Multiply so that you get common denominators. Add together your two partial fractions. You can cross multiply, but it results in quartics, and I'm guessing you don't want that. So instead, multiply to get your common denominators, add your partial fractions, and then multiply by whatever that denominator is to just get it out of there. Yeah, all of these are. Hmm? Yeah. I said, yeah.
Or you could do x squared plus 6.
2x squared, x squared, 3x squared.
Plus 2x.
X squared, 4x minus 12 plus 12 cancels. X squared plus
I probably added them and just thought it was right.
2x.
I don't know.
Two.
I don't know. I got.
What do you mean minus 24? Should be 0.
Yeah. It's a negative 12. Because there's a negative right there.
Yeah, it might not be too visible on your sheet. There's a gap here. Yep, on the printed version, I think it's a little fuzzy and it kind of blurs together. Okay. So this guy needs an x. This guy needs a x plus 6. And if I take the the whole thing by that x squared plus 6x, the whole denominator cancels. Bye-bye. Leaving negative 12 is 2x plus x squared plus 6x minus 2x minus 12. Combine like terms and add 12 over. I'll get x squared, 2x minus 2x cancels, plus 6x. If I add 12 to negative 12, it's just gone. So we get, wait a second. But I can't. So what's the answer? There is no solution. And y'all, just yesterday with Algebra 2, reviewing, what was it? We did complete the square and then quadratic formula. We were talking about the discriminant, about how you can have one solution to a quadratic. Well, no, you don't. You don't have one solution. It's actually the same solution twice, right? And then I started saying things like, yeah, you could do all that work and there's actually just one solution instead of two, and then you can do all that work and then there's no solution. And then you can do all that work and then there's imaginary solutions. And then you can do the entire honkin' problem and it turns out there's no solution. Just wait until we get... No. It's going to be great. So, I do want to see... Where's the thing? There we go. No. It's too easy. That's it. I will do one more, just to be safe. One more.
Yeah, I should just invest in some Clippers.
I should do this.
6a squared minus 3a. 6a squared minus 3a. Minus 7a. 6a squared.
Oh,
A minus
I didn't see the question.
minus. Would you agree that that's what's needed for common denominators on that side? Life hack. Do that so you don't forget your negative. Then I can't just make the denominator disappear because on the right side I don't have a denominator. Okay. So I have the option here of either cross multiply. So, okay, let's fix this. We got 6a squared minus 3a minus 8a is minus 11a minus 4. All over that stuff, which is 4a squared minus 1. Okay, if I were to multiply out and combine like terms right now, that's where I'm at. Yes? No? Six a squared minus 3a. Negative 8a. Negative 3a, negative 8a is negative 11a. Negative 4. And then on the denominator, they're conjugates, so my middle term disappears. So my option is to either, right now, cross multiply and set them equal, which gets me 6a squared minus 11a minus 4 is 4a squared minus 1. Or, isn't that exactly what I'm going to get anyway if I multiply the whole thing by 4a squared minus 1? Right? Because it'll cancel here, but then it'll end up right here. So whether I cross multiply or just multiply by that to get rid of the denominator, I have the same thing, the green stuff. Everyone to one side of the bus and solve. Subtract 4a squared. Add 1. Uh-oh. You sound so excited about that. We have to complete the square or quadratic formula because it isn't factorable. Usually it is. That's why I picked this one. Okay, I'm going to say a squared minus 11 halves. A is 3 halves. Jeez, dude. Divide by a. Variables left, constants right. Half of 11 halves is 11 fourths. 11 fourths squared is 121 sixteenths. You're like, why are you doing this to me? Because you're going to have to complete the square twice per problem when we hit conic sections. We have to be good with this. Call this a minus, it's always plus b over 2, so 11 fourths. This is always half of b and the square root of c. It's always the same. Common denominators by 8 by 8. 24 plus 121. 145. 16th solved by square roots. A is, what, 145. I don't think anything goes in there. Like no perfect squares, right? 145 minus, yeah? Boo. Okay, so 11/4 plus or minus the square root of 145 over 4. They don't always come out nice. All right. Problem encountered. How do I check that? Just hope for the best. Okay. I'm going to show you the cheater way to check it, especially with testing season right around the corner. Okay. So let's say we had 11/4 plus, what was it? Square root of 145? 145 over 4. Womp.
If the bottom was a square root as well, would you do a square root on the bottom and then 4?
Ew, I would just simplify that.
We can say it's 3.
I would rationalize it. Times squared 3 times squared 3. No radicals downstairs. I stir up the girls, give them bad ideas.
Huh?
Maddie's saying, what if I had this?
You want to fix that before you...
No radicals downstairs. I stir up the girls and give them bad ideas. You need to put the radical upstairs where you can keep an eye on them.
Until it's that one guy.
Mr. Devon Larson, when I did Algebra 2 in 1999, said that about your first boy-girl party. You can't have the radicals downstairs because they're going, yeah. So, anyway, I have an answer. I have an expression. I can check said answer without having to plug in the actual value here because the calculation is in my calculator. I can now say 3 times my answer over 2 times my answer. Was it plus 1 or minus 1? Was the first one?
Plus 1.
Plus 1. Minus 4 over 2 times my answer minus 1. Okay. Now, 1 is now my answer. So if I try to do this again, it's not going to work. So I can manipulate that and say this. No. Okay. I can say that, and then this will use whatever my last answer was. Okay. So if you know the calculator mojo, you can get around having to think, but you still have to know how to use the tool. You know what you're doing, you just don't want to. I know how to wash the dishes. I don't care. I'm still going to put that whole honking pan in the bottom because I don't want to. Okay? It's usually above negative somewhere on the bottom row on any scientific calculator. Like that $10 Casio from Walmart. It's above the negative in the bottom row. Okay? So, you got ways to check them if you need to.
Wait, so you drop the answer down, you just scroll up to it and then hit enter on it?
if you're trying to use the answer itself, you can just hit second answer. If you're trying to drop an entire calculation down, arrow up and highlight whatever it is and hit enter. What you got to be careful about, though, I learned this the hard way. Let's say I was trying to type this again, but I wanted this calculation to be on my denominator. I can't do that. When I hit enter, it won't put things on denominators. I don't know why. It just won't. Okay? So there are limitations to it. And then the last thing was blah, 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 blah. Do that with words. Okay? How many of you took our DC electronics class? I think they only offer it like every other year. But we have an electronics class. Or at the very least, we should remember this from probably physical science. It looks familiar. Okay. You'll hit it again when you do physics. Do physics. You just got to know that if you're going to take physics, everything that I say about accurate answers, he doesn't do that.
Oh my gosh, this wash could drive me insane.
Because
Great, but the fact that she rounds her answers while she's solving,
I have so many kids who do pre-calc and they get used to the true ways of the force, like actually having real answers, the perfect expression answer, and then they go and take physics, and Gabe will actually round on this step to use in this step, then round that to use on this step, then round that to use on this step, and by the end, y'all ever played telephone? Or what's that game that you tried to get me to play? Where it was like telephone, but yeah, where you doodle sketch it instead. Cartophone. Gardic phone? Okay. Yeah. So that's why you don't want to round your answers as you're working. But I know that our science teachers do. So
There are two ways to solve any equation, and if you don't have anything, just
ew. All right. So if you will, blah 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 words. The diagram of an electric circuit shows 3 parallel resistors. Big R is equivalent resistance of the 3 resistors. So when you have 3 resistors in a parallel circuit like this, they're all going to kind of dampen down how much amperage can go through it. That's 3 resistors all saying, whoa, 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 slow down there. Okay? Don't shoot the entire lightning bolt through. Tone it down. And that's what big R is. It's the total resistance. But then it gives me a bunch of, well, it's not really a 4-variable equation. They say R sub 1 is twice the resistance of R sub 2. Okay. Twice the resistance of R sub 2. So I'm just going to replace that right now with 2 R sub 2s. R sub 3 is just straight up 20 ohms. All right. But I still don't know this guy.
R sub 1 is twice the resistance, not the...
Yeah.
You put the first, you put like what it thought you...
R sub 1 is twice the resistance of R sub 2.
Oh, got it. How many phases is this, man? Just blur it out.
Yeah?
At the bottom it says suppose the equivalent resistance is equal to 10 ohms, so the R...
Okay. And then, like, we got here. And then people started yelling at me. Suppose the equivalent resistance is equal to 10 ohms. So now I know, because that's big R. There you go. So I'm down to 1 variable again. That's substitution. Find r sub 1 and r sub 2. So if I know this, I'm going to get common denominators again. What's this guy missing? Well, okay, what's the least common denominator between all of these? Not greatest common factor, least common denominator. What is the smallest thing that 2r sub 2, r sub 2, and 20 will all go into? Don't need 40. 20 r sub 2, right? Because 2 goes into 20. This guy's missing 10. This guy's missing 20. This guy's missing r sub 2. Don't all of those now have 20 r sub 2? Common denominators, just like we were doing. So, we got 1 over 10 is 10 plus 20 plus r sub 2. I'm going to rewrite it like this because I like my variables first. Over 20 r sub 2. I can choose to multiply the left side to also have 20 r sub 2 as a denominator. Or I can just cross multiply. Right? Same difference. If I multiply this way, we got 10 r sub 2's plus 300 is 20 r sub 2's variables to one side. Divide. And remember that it said r sub 1, the first resistor, was twice the resistance of r sub 2. So r sub 1, 60. Oh, sorry. Almost. Now, how many of you, this got ugly because you had those subscripts, r sub 1 and r sub 2? Extra numbers. Okay? If you don't like that, there's nothing wrong with starting the problem like this. And then just off to the side saying r sub 1 is A, r sub 2 is B, r sub 3 is C. If you just don't like the subscripts on there, you can always change it as you work. Just make sure you know what's what at the end of it. It's just an example of blah, 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 blah. I can do stuff with formulas that have variables on denominators. Solve. Ella transferred out of our class.
Are you serious?
Yeah.
You said it like with a little smirk, and I was like, I think she's
Well, you said, am I serious? I said, yeah. No. We found a hiccup with stuff, and there was things that needed to be taken care of, and now she's in a different class. That's it. Nothing bad, just this wasn't doing it. Then change it.
Making me do it.
Pluses look like T's, T's look like pluses. S's look like 5s. What was the other one? 2's look like Z's. Okay. Did I do a dumb? Or is it not factorable? Like, it is 9, right? Like, I'm not... If it was 10, it would have been perfect.
It was 9.
All right.
Also, 85 is not.
Okay, so... What's that? Negative 9. 11 halves. 121 fourths by 4 is 324. 324, 121, 203?
I have a question.
Scored in 203 over 4? Hi? What?
Is that an I or a 1? In the orange. On the left.
It is a 1. I will always do I's with a tail.
Okay, because in the equation it's an I.
But then it says at what time is the current 1 amp. So I replace I with 1.
When you put the square over, it's 121 fourths minus 9.
I'm pretty certain.
And then that would be 85 fourths.
I would be willing to sacrifice and grab
Buddy.
Half of that is 11 half plus 121 fourths.
And that's 36 fourths. So that's 85.
Green. There we go. Or quadratic formula, whatever your jam is. By 4, negative 36, 5, 6, 30.
It's 157 fourths.
Yeah, that is 85. Okay. It's not square root yet.
Oh, it will be. Yes.
Oh. No, I had it. Forgot it was a name.
Scored 85 is going to be awful close to 9 over 2 is about 4.5, so like 4.55 or something. And then, what, 5.5? So, awful close to 10 and awful close to 1, I think. No! We're already 3 days behind.
Well, we had a snow day.
No, general level of distraction. And that's on me too, because I enable it. Subtract 1.
I got mine.
No, I went that way. But you'd also have a negative t squared and a positive 11t. It's the exact same thing, just different signs. So, about 1, about 10, ballpark. Okay. Take 5. Get up, do things, whatever. Go to the bathroom, I don't care. Take 5. Because I need to pee.
Actually, yes.
Yeah, I'm kind of. I'm in this situation.
Why?
Because I kind of want to go to volleyball game tomorrow. So my dad wants me to go hunting.
Yeah.
So I'm like,
I wanted to go to super hunting.
Come to the volleyball.
You're gonna go tonight.
What are you guys hunting for?
Steer.
You come in my yard and you get all of them.
Like easy.
Does anyone have time?
What?
Oh. Oh.
I want to go see the house.
Well, they actually will take that. That's dumb. Did you have to? Oh. To you? Yeah.
What happened?
Called me after school. Yes. Yeah, what should I do with it? What should I do with
It's
it?
against the law to have Tylenol.
Put it in
Hiding
your
soul of
pants.
it.
Put it in your pants. Actually, give it to me. Put it in your pants. Put it in your bra or something.
So big.
Wait, you want I used to. So I'm gonna get you in trouble. Andrew.
You good?
Yes.
I killed you on. Put it in fire.
I feel like sometimes when you see like broken because
That is a good thing you break fast on. I'll tell you what. They're still good. Let me make these.
This is. I know. And I more like that one and have it just a little piece.
Hey, at least 2 for me, please.
Yeah, but if
I checked this up for.
in the school bathroom,
I heard there's a police dog.
just kidding. Yeah.
Yeah, I guess it's a life picture.
I have no idea what's in my bag, so it's either good or bad.
Yeah, everyone's doing like the pride survey or something.
What about Pride Survey?
Is it because of that?
The fact survey was like, how many times have you done crystal meth in the past 30 days?
Yeah,
It was like the
they get
same
like the most
questions
innocent
over and
people on that
over.
grade, kid.
I bet you
Oh, your mom had to sign it.
your
Oh.
parents had you, or like give
Your
you
parents
permission
had
to
to
take
give
it.
you a permission slip, and then you had to bring it to the office.
I
did
take
because I
it
wanted
and
the
just like
candy bar.
say
I didn't know there was a candy bar.
I'd say I do it.
To.
7 times a day.
Just to put all the drugs every day, all day.
I smoke 3 packs a day. You know what I do? I grab the whole pack, like the whole thing, and go, and I throw it away.
I've seen cartoons like that. Bugs Bunny.
Exactly.
No. They're not allowed to like. You're not just like put your name on it and they're allowed to say who took the test. They can like. Oh, you can?
That's true.
It's online?
Yeah, it's
Then
online.
you're chill.
Yeah, exactly. So I'm just gonna say,
They're
I'm gonna fully got my way through it. They'll be like, what the heck? What is
legally
this
they
shit?
can't say who took
I
it and
legally
stuff like
hold a killer. No.
Okay,
Is there pounds?
since it is a topic of discussion, a little bit of history for you. They call it a pride survey now. It used to be risk behavior survey.
Oh crap.
Okay. The risk behavior survey used to be an opt-out model, meaning everyone in the state took it. Everyone. Unless your parents specifically filled out the form to opt you out of it. That meant, because all of those surveys are anonymous, they actually got decent data. But, as you know, our state is fairly conservative, evangelical, like pearl clutching, the children, because they think that if we have you take this survey, it's going to give you bad ideas. Because if I ask you the question about how many times per the last 2 weeks you have smoked marijuana, it's going to make you want to smoke marijuana. If I ask you about sexual activity, you will now go to an orgy. Okay? Like, no, legit, that is what our legislators said. Okay? Our legislators said that by forcing all kids to take this, we are exposing them to ideas that are inappropriate for their age.
Those ideas are already there. Like
So, about 5 years ago, they switched it to an opt-in model, which says you don't have to take it unless your parents explicitly sign the form and return the form that says you will take it. Do you know what parents are going to actually sign and return the form? Parents who think, of course my kid can take this, because they don't do any of that. Or parents who have the time to do it, the energy to do it. You all know about, you all took Algebra 2, you took Algebra 1, you know about sample bias? Self-selected surveys, self-selected samples, are ones where people choose to respond. Good indication of that, how many stars on a review? Have you ever looked at the reviews for somewhere like, I don't know, Killian's? But what are the reviews? They're all like 5 stars, or 1 star, I would give it a 0 if I could because she didn't bring me a refill. Right? Like, there's no middle ground. The people who respond to the surveys are the ones who have a strong opinion one way or the other. So it doesn't give you good data. So our Pride survey gives horrible data. But that's what the legislators wanted, because now they have data that says, look at our good kids. Our good kids don't do any of that naughty stuff.
Well, you have to do one. Paul, it's your job.
Our hopes and dreams rest on you, Paul. Click every button you can. Okay? Like, but just, there you go. I believe cross-curricular content is worth it because we talked about sample bias and it's slightly mathematically related. So, back to the actual stuff we're doing. Y'all, thanks for hanging in there with me. I just don't want to be here today. Like, but we have to do the thing. I'm trying not to let it affect me, but I know it is. Hang in there with me. I want to go home and sleep. So, all right. NonLinear inequalities. I'm usually here around 7:30. We usually get up at 5. It takes time to get children ready so I can leave, so I can bring child to preschool, so I can get here in time. So, you all see function. Function is polynomial. Polynomial has zeros. Cool? So if I asked, where is the function of x less than or equal to 0? No. Remember, x is the input. f of x is the output, in this case the y's. So if I'm asking where this thing is less than or equal to 0, I'm asking where is it that line or below? Where it was negative, where it was negative, where it was negative. So I effectively say from here to here, union from here to, what do I do with this if I say or equal to?
Yeah.
But is it less than or equal to 0 at that point? Yeah. So it never actually stops being less than or equal to 0, all the way to infinity. Okay? So an inequality is when is the function less than or equal to, less than, greater than or equal to this number. The easiest number in the world for us to set it in equal to is 0, because I know how to find zeros. What's going to change about this particular function if I just do that? Now what? It's right here, but not equal to. It's right here, but not equal to. So how do I say that? Yes, sir?
So is the last one brackets then?
That was just to infinity.
Yeah. Yeah. Okay, so here I'll be from -4 to -2. Union. Because I'm specifically saying less than 0, not less than or equal to, I'm going to have a union that says from 2 to 5, a union, and then 5 to infinity. But that's everywhere where my function is less than 0. Could you do the same thing for greater than? Greater than or equal to? So on a polynomial, the places that it switches from greater than or less than 0 are the zeros. That's it. That's how you find these. Go find all the zeros of the polynomial and then test the intervals in between to determine if it's positive or negative. You just make this cute little sign chart here, okay? That's it. Now, these ones are easy because they're parabolas. We should know how parabolas work. If I add 3 to the other side, y'all cool with that? Nah. Graph the parabola. Show me you remember Algebra 1. Come on now. Graph the parabola. I don't care how. It's an ACT. You have a TI-84 next to you. You got a piece of paper. You have the last 4 years of algebra. Come on now. Because the only thing that I care about are the zeros, right? Don't give me that stink eye. The only thing that I care about are the zeros. And if I'm asking where is parabola greater than 0, well, it's greater than 0 here and here. So my solution is as simple as negative infinity to 3, negative, parenthesis or bracket,
Bracket. No, parentheses.
not equal to, parenthesis, union 9 to infinity.
Why do we even do it right? When I could have just solved by backgrading it.
That's what I'm getting at. Okay? You find the zeros because the zeros are what matter. Now, you should know how to graph this because y'all remember negative b over 2a? Stick a 3 in there. 9 minus 18 is negative 9. Negative 9 minus 27 is negative 36.
That's the vertex.
So I have a vertex at 3, negative 36. Which should make sense because parabolas are symmetric and these are 12 units apart. So 6 units that way is my axis of symmetry. You don't have to. I'm just reviewing stuff. Or maybe I have x squared minus 6x minus 27. Maybe I turn it into vertex form. X squared minus 6x. Complete the square. Half of negative 6 is negative 3. Negative 3 squared is 9. Plus 9 plus 9. X squared minus 6x. Or x minus 3, the quantity squared. There we go. Bring that over. I now have the function f of x is less than x minus 3, the quantity squared, minus 36. HK, vertex. You did all of this in Algebra 1 and again in Algebra 2. We also reviewed it in Chapter 0. Okay. So, this is when I say, before y'all take an ACT, we should probably do some review. So, however you're going to do it, please tell me, when is that particular parabola less than 20? When is that particular parabola greater than 4? Those are expensive, be careful.
Yes, that's not bad.
That was some like grade A Mean Girls look you gave me. That hurt, Taylor.
I don't know how to do these. So the black magic would work. And I may have gotten sick.
You scared you like every second.
Alright, let's go on.
Wait. I don't know.
Okay.
you say 7?
Basic factoring. I know that this thing's going to have zeros of -7 and 2. Okay, what kind of parabola is it? Does it open upward or downward?
Wait, what? Oh, sorry.
Does it open upward or downward? It's a happy parabola, right? It's got a positive a value. Remember, happy. Okay. So if it's going to do this, and I don't even care where my vertex is, literally, the happy parabola, right above Holden's head right there. Okay. And I ask, where is this less than 0? Well, it's everywhere between -7 and 2. Don't overthink them. Find the zeros and, okay, now let's say I just found those zeros. That's all I found, and I don't want a graph on it at all. I know I have a 0 at -7. I know I have a 0 at 2. Test the intervals. If this is your parabola that you're testing, pick a number less than 7 and throw it in. I'll throw in -10. 100 minus 50 is 50. Minus 14 is 36. That's a positive number. Pick a number between -7 and 2. Throw it in. How about 0?
Yeah.
0 minus 14. That's a negative number. Pick a number bigger than 2. Pick 3. 9 plus 15 minus 14 is 10. That's a positive number. So you find the zeros. The zeros make your number line. Test the intervals in your number line. That's it. Now, how I test those is entirely up to me. Could I come back here, clear, clear, say x squared plus, what was it, 5x? Yeah, 5x minus 14. Table settings, switch that over to ask. Could I do this to test my values and say -9, 1, and 6? Positive, negative, positive. I tested in my intervals around those zeros. Okay. Now, this, it's got a 0 at 4, but I want to know when it is greater than the line 4. Do you want to find the intersection between the parabola and the line 4, or do you want to just move everything to one side so you can find the zeros? Okay, that's why we do this, because it's easier in most cases to set it equal to 0. So I have x squared minus 8x plus 16 is greater than 4. Subtract 4 over. Factor. Solve. Get your little cheater number line and say at 2 and at 6. Okay? Once I know those two numbers, is it a happy parabola or a sad parabola? So I don't even need to test the intervals if I know that. I can just say it's going to be positive, negative, positive like that, because I know that's what a positive parabola does. Or I can plug in 0, get a positive 12. I can plug in 4. 16 minus 32 plus 12 is a negative 4 or 8? 8? Okay, negative number. Plug in a 10. Okay. So, if I see that and I'm asking where is that greater than 0, I'm going to say negative infinity to 2 union 6 to infinity. That's where this thing is above 0. All right, just to prove it, what if I came back here, x minus 4, the quantity squared, and 4. The parabola, the line. Look at where it hits. So when I ask where is the parabola above 4, it still gives me the same answers, right? But I just shift that whole thing down to my zeros because it's easy to find zeros because we know how to math. Most of us. Depends on the day and the caffeination. Okay. Too bad.
Alright, come here, calculate fella.
You can't just do it because you can't do it from 0.
You can either factor it using that split a term trick, or you can gaze into your crystal ball and determine what you feel very lucky about.
No, I want to get factored.
Good job. A lot.
Hmm?
We can just look at the zeros.
Oh, that's not going to work. I split it wrong. Oops.
You're on the right track.
No, I split it wrong. It was factorable to that point, but then the binomials weren't the same. Because I can't think today.
I have the answer.
So, we're going to feel oh so lucky about what numbers? You said -1? What do we feel oh so lucky about?
3.
I bet we feel pretty lucky about a -2/3. So, my number line has a -1, has a -2/3, has a 3. Now, a bunch of you are already looking at your screen because that's how you felt lucky about some numbers and saying, I bet I know where it's positive or negative because look at the screen. So I don't really need to test the intervals to do that, right? But what if I factored to find zeros? I don't have the screen in front of me. Look at the title of this line, of this example. Using end behavior. Wasn't that a positive cubic? Positive odd? Where does positive odd always start? Down at negative infinity. It does stuff, and then it goes to positive infinity. Each of these zeros occurred once. So what's their behavior at each of the zeros? Like a line. So I know that my graph is going to come up like this. Because that's just the behavior of the zeros and the end behavior of a positive odd polynomial. So I don't need to look at my screen to cheat my way through the problem, you bunch of... I can instead do this, which is in fact the example and why what I'm supposed to do. If I know what the polynomial's behavior is going to be, I don't need to test the intervals because I know what it's going to do in there. And then it asks, where is this thing less than or equal to 0? Well, right here. Negative infinity to... You know what? Get rid of that. You come up here. You go there, you go there. You go there. You go there. Check out my number line. If I know the general behavior of it, I should also, at the end of this thing, have effectively a number line for my answer. Where is it less than or equal to 0? Right here. Union right here. Like that. There's a negative in there. It just got run over by my bracket. Okay? You should be effectively creating a number line with your answer. So, what I'm going to caution you about, it's going to be very, very tempting to just look at the screen and write the answer. Because there's my zeros. I see where it's above or below. I'm just going to write it. Have some work to back it up, even if it's just synthetic and then that little cheater number line. Have some work to back it up. Okay? So, I'm going to skip A because it's just another quadratic. Let's do B. But, yes. Four, three, take it out, 9. 45 is 3 and 5. That won't work. No, other way. Dang it, did it again. -3?
Negative 3 to the multiplicity of 2.
What?
A minus B or A plus B?
It hit negative 3 twice.
It does, yeah.
What? That must have plugged this in. Nah. I think I put it in the wrong place. Whoa.
Okay.
Did I plug in?
No. What do you feel lucky about?
That's much better. I plugged it in real time. Much better.
And then negative 3. How? And then 5 halves.
Okay. So if I see this little number line here, I know that negative 3 and 5 halves are my zeros. And I know that negative 3 happened twice. It's a positive odd, so I know I'll start down here at negative infinity, and it will bounce off like a parabola, go through like a line due to multiplicity. So I don't need to test anything else here. I can just write my answer. It's negative, negative, positive. Where is this greater than or equal to 0? Now, most kids are going to get this part. Do you remember how we wrote the other one? Because it's just negative 3. Because it's only a single point, right? Because it's only a single point, we don't write interval notation. Interval notation is when there's an interval. Your interval cannot be here. That's how many of you have been in sports and your coach yells at you, move! Just move! Do you just stand there and stare at him? Eh? Yeah. My junior year, we got 2 brand new football coaches, completely turned the program around. Our O&D line coach was a 6'4", 330-pound man. Braided dreads. Fresh off of the UND national championship team, defensive end. He spent his summers playing professional arena league football for the New York Dragons. So when he gets up in my face, you trying to make me mad? No, sir, I would never intentionally offend a man of your size. Like, when he tells you to move, you're gonna move. And like, he was fast too. He was wicked fast. He would say, if any one of you can beat me over to the sled, you only have to do 3 rounds. Otherwise, you're gonna do 12. Ready? Go. And he'd take off, and he would beat our skinniest, fastest kid. Like Keenan. Keenan's like, holy crap. He's pretty impressive. Oops, I just kind of set a school record. Sorry.
Like his first speech back, he wants to do a 4:15.
Ew.
He holds a 4:23.
So, maybe not that fast. I might be exaggerating a little, but dude still beat all of us hands down, including our tight ends. So, anyway, sometimes we get weird answers. Oh! These ones are easy.
It's been a week.
These ones are super easy, though. All right. This one. Find its zeros. So, quadratic formula or complete the square. Go. Negative 8, 5 halves, 25 halves, 25 fourths, 25 fourths, and 5, negative 32, 5, negative 7. Confirm, please.
How would you
I forgot. Wait.
Yes.
Oh, you don't need
Why do you have 7?
You don't need that in a square root. You can just have it instead of because your thing was 49.
No.
I don't know. I'm always
If you move 8 to the other side, you have a negative 8. So negative 8 plus 25 fourths will be a negative 32 fourths plus 25 fourths is a negative 7 fourths. Okay. I will find that out in a couple weeks. I got retested. Genius. Like, I don't know. The last time I was tested was like 12, 13 years ago. So I was 2 points shy. Genius is 140. I was at 138. But if I hit 140 plus, then I can apply to Mensa. So Mensa is the official smart people club. You literally have to be a genius and have an IQ test to prove it to get in. It's just because smart people are usually bullied in school. So then they make their own little club so they can bully people who aren't as smart as them and they can feel better about themselves. So, anyway, it's a positive parabola that has no real solutions. Where is the parabola? Above the x-axis, right? So when it asks, where is this less than 0? No. Where it asks, when is this greater than or equal to 0? Everywhere. Right? No, look at the parabola. Look at this horrible, horrible parabola. Where is this less than 0? Nowhere. Where is this greater than or equal to 0? Everywhere. Sometimes you get weird answers because of that. Okay. Find the zeros. Go.
He's doing it without looking at the board. That makes sense.
X 5 squared. X plus X minus 5 squared.
Oh yeah, because X minus 5.
Don't you tell me no. X minus 5, the quantity squared. Remember our perfect square trinomials? But what does that mean in terms of the parabola when there's only one 0? The vertex is on the x-axis. So this parabola looking like this, where it hits at exactly 5, 0. So when I ask where that one is greater than 0. No. Negative infinity to 5, can't touch us. And 5 to infinity. And if I ask where is it less than or equal to 0? 5. Just 5. Okay. Those are fast. I see 3 minutes. Go. All of them, because it's the same 2 quadratics.
Boy, I tell you what. It's all real numbers.
So we get to say,
Yeah, I swear.
No, because y'all are just going to write down what I write. Do it.
This is x minus y squared, which means that
wait a minute.
less than or equal to.
Okay, so it means less than or equal to. That means it's only 1. This one is 1. And this one is 3 1. This one. Oh, so you do the.
Because that's what we did earlier. Because it hits right on 1, doesn't it? Yeah, so that much.
Tell me.
That's how you add it.
Oh, because that makes it 0.
Yes. And that makes it 0.
1.
What? Wait, no, I was looking at the wrong thing.
Yeah.
I was right.
Wait,
I was going to copy that. It's literally the same thing.
It wouldn't be equal. We did the wrong
I mean, not the same order.
I'm finding the zeros.
Oh, it's the other way around.
Oh, that's it.
Okay. Y'all, you don't have to burn the brain steam on this. Could you just dump that in your calculator, see it never touches the x-axis, and say, yup, everywhere? Could you look at it and say, when is that less than or equal to 0? Well, it's above the x-axis. No. I can look at my graph and see that it touches at exactly 1. So where is it less than or equal to? Just at 1. Okay.
Finding the following students to the office. Adrian Knopf, Nate Jensen, Aiden Ripley,
Hi.
Peyton Olson.
I don't know. Someone else did it. What?
Somebody out. Can I have a new sheet so I can rewrite it so that I don't have to erase it again? Do you understand? Somebody else.
I don't have another one. I'd have to print it.
Can I
Just do it on a separate sheet of paper. Yeah. Same difference. I'm still going to see what your answer is.